Hello everyone, welcome to this video. In this video, we want to build a simple AC circuit. So this is whenever you open MATLAB, you will see the screen. So here we have the editor window, the command window, the workspace, the current folder window, and the details window. So we need to use Simulink. So once we are on at the home tab, you go in this strip and you will see that we have Simulink here. So we need to click on Simulink, and then we will have this window open and we select blank model. So of course, these are different projects in different topics. So what we need to do is to select a blank model. So here is our model. Let's maximize the screen and let's start with saving this model. So I will save it as AC circuit. And in MATLAB, you cannot use spaces, so we can use underscore between AC and circuit, and I will save it on the desktop. So now my model name or title is AC underscore circuit. Okay, so I want to build a simple AC circuit. So I need to have here an AC source, AC voltage source. So I go to the library and I will go to Simscape here. And once you find Simscape, you find electrical. And in electrical, you go to specialized power systems. And then you will go to sources. Here we have sources. You click on sources, then you will have different types of sources. So we need to have AC voltage source. So I will drag this AC voltage source to my model here. And as you see now, I have my AC voltage source. So now let's set the values of this AC voltage source. So I will do double click. So I want for its value to be 28.284 volts. So this is the peak amplitude. So this is the maximum value. For the phase shift, I will keep it 0. For the frequency, I will have it in this model to be 50 Hertz. And then I will do apply and I will do OK. And in this model, I need to use two resistors connected in series. So it will be a resistive AC circuit. So again, I will go to the library, to Simscape, and from Simscape to electrical, and from electrical to specialized power systems, and then to passives. In passives, I will look for the series RLC branch. So this series RLC branch, I will drag it to my model. And as you see, it is RLC. But we can select the branch type by clicking, double click. You can select the branch type and I will select R. So if I do apply, you see that it is now only resistance. Let's have the value of this R 3 ohms. So apply and OK. So you can type here, for example, R1 is equal to 3 ohms. So you will not forget what is the value here. And I want another resistance. So I do right click, I do copy, and somewhere in the system, I will do paste. And as you see, I have another resistance here. So I need to change its name and its value. So I will do it R2 and let me select 2 ohms for this resistance. So I will double click here and I will change its value to 2 ohms. Apply and OK. Now I have these two resistances here, so I can connect them in series. So since I have a single loop circuit, then I will have one current in this circuit. So I need to have a current measurement device. So again, I will go to the library, Simscape, and from Simscape to electrical, to power specialized power systems, to sensors and measurements. And here I have the current measurement device. So I will bring it to measure the current in my circuit. So, and now I can connect the source, the positive terminal to the positive terminal of the measurement device, the negative terminal to the positive terminal of the resistance, one resistance to another resistance, and then I need to complete the circuit. So now the circuit is complete and I have a simple resistive AC circuit. So now I want to see what is the value of the current in this loop. So I need to have a display. So again, you can go through the library to bring the display, or you can double click anywhere in the model and you type display. You see I typed only the first three letters, and now I can see the display here. So I will bring this display and I will connect it to the current output, current measurement output. So it will show me the current in this circuit. So I will use I, comma, and this current will be in amperes. So now this display is I, comma, amperes. So it is the current and measured in amperes. Also, I need to have, and of course, this is AC current. So we need to connect it through an RMS block. So we cannot connect it directly like this. So let me bring RMS block. So I'm typing RMS, and this is the RMS block. Now I will delete this line and I will connect the RMS block first, and then the input of the RMS block is connected to the output of the current source. Why I'm using this? Because this is AC current, and AC current will be changing all the time. If you measure it, you will changing all the time. So we need to have the RMS value. You make sure to double click on the RMS block and to match the frequency with the source. So the source frequency was selected to be 50 Hertz. So then I need to select here 50 Hertz as well. So I will do apply and okay. Now we need to measure the voltage. We need to measure the voltage. Before measuring the voltage, let's have the environmental block, which is power GUI. I'm typing power and I see that power GUI is here. So I'm selecting it, having it anywhere in the system, and it will not be connected to anything. It just showing us that this model will be solved in continuous mode or in time domain mode. So if I run this circuit, so I will see that I will have a current which is 3.29. So this is that current. So let me select the stop time to be 0.02 seconds. And I'm selecting this value because this is one period. So if you have a frequency of 50 Hertz, so the period is 1 over the frequency. So it will be 1 over 50, and 1 over 50 will give you 0.02. So this will be the period, which is 20 milliseconds. I will do run again, and I will see that the RMS value now is 4, because I'm selecting it or I'm calculating this RMS value over one period. Okay, so now let me measure the voltage of the source. So I will bring a voltage measurement device. So I'm typing measurement, and here is the voltage measurement device, clicking here, and then I want to measure the voltage. So I want first to flip the voltage measurement device. So I'm doing right click, going to flip, and I will flip it left to right. I will connect the positive terminal with the positive terminal, the negative terminal with the negative terminal. Again, I need an RMS block, so I will copy this RMS block. So I will copy it, and anywhere in the model, I will paste it. And again, I need to flip it. So let me flip this RMS block by clicking right click and then flip left to right. And now I can connect it with the voltage measurement. I need to have a display, so let me copy this display and I will paste it somewhere here. And again, I need to flip it. So let me do right click, flip and rotate and flip block. So now I can connect it and I need to rename it to, because it will measure the voltage source. So it will be V source and comma, this voltage will be in volts. Okay, and this voltage will be the RMS voltage because it comes after the RMS block. Now let me run the circuit again and I will see that the RMS voltage is 20 volts. And if you go to this voltage source, so this is the peak amplitude 28.284 volts. And if you divide this number by square root of 2, it will be 20 volts. So this is the RMS value and this is the peak value. And the peak value is more than the RMS value by the square root of 2. So now I want to measure the voltage across these resistances. So again, I need to have a voltage measurement block. So this is the voltage measurement block. I need to flip it, let's say, rotated. So let me rotate it in a clockwise direction and again rotated in clockwise direction and again rotated in a clockwise direction. So and now I have the plus terminal at the positive terminal of the resistor, the negative terminal connected to the negative terminal of the resistor. I need to have some displays. So let me have this display to be copied. So I will copy it and anywhere here I will paste it. And now this display will show me the voltage across this resistor. So let me rename it and I will say that this is VR1, volt. And the same structure should be built for the other resistor. So I will copy this display, this line, and this voltage source. So now I will do right click, copy, and anywhere here I will do paste. And now I can use the arrows or the mouse in order to have it across or here near to R2. So now I will connect this one to R2 and this one to R1. And again, I'm forgetting the RMS block. So let me rename this first. So it will be VR2 and V2. So again, I should to connect it to RMS block. It is incorrect to have it without RMS block. So let me make some space here. And now I want to copy this RMS block. So I will do copy and somewhere I will do paste. I will bring this RMS block connected here. Let me try with this one. Okay, this one is connected. So let me move this one again and like this. So I want to copy this RMS block. So I will copy it and then I will paste it. I will try to connect it now here. Okay, I see it is not connected. So let me remove this line and then I will connect it like this and I will connect it manually like this. Okay, now we have the voltages connected. And again, if you are measuring, it's a AC variable, so you need to have the RMS block, and the RMS block should be set with the appropriate frequency value, So let me bring this, make it nicer. Okay, so let me run the circuit now, and I see that we have a 20 volt RMS Here we have a 12 volt RMS dropped across this resistor. We have 8 volt RMS dropped across this resistor. Their sum is 20, which let's say fulfills KVL, which is Kirchhoff's voltage law. The sum of the voltages around a closed loop should be 0. So here we have a 12 plus 8 and minus 20. The source voltage, it will be 0. And if you divide the 20 by the sum of the two resistances, 20 divided by 3 plus 2 will be 20 divided by 5, and this will be 4 amperes. Now what we need to do is to measure the power. So let me have a power measurement device. So again, I'm typing measurement. Here is the power measurement device. And again, for the power measurement device, I need to connect the voltage. You need to make sure that you connect the voltage before the RMS block. So it should be connected before the RMS block, not after the RMS block. And I need to connect the current value as well. So the current value is from this current. And let me drag this line like this to make it more clear. And I need to have one display to show the power. So we need to show only the active power. We don't have reactive power because this is a resistive circuit. Let me rename this, and I will type P source and comma, and this measured in watts. Of course, if you want to see Q here, you can see by connecting another display. So let me type, paste this display here, connected to Q, and I will type here Q of the source, and the Q is always measured in volt ampere reactive, so it is in bars. And here for the power measurement device, I will type here source, so it will be the power of the source. Now I will run the circuit, and I see that I have more than values here. Why is that? Because I didn't select the appropriate frequency, which is 50 hertz for this circuit, and the number of harmonics. I need to keep only one because I'm calculating for the fundamental harmonics. So I will do apply now, and then OK, and I will run the circuit once again. So what I see that the power here is 80 watts. So this source delivers 80 watts. That should be dissipated in these two resistances. And I see that the reactive power is 3.2 times 10 to the power of negative 15. So as you see that this is a very small value. So let me try to, if I do double click, I select, for example, short. So this is short. Okay, so this is a very small value. So either you, this is almost 0, equal to 0. Now let's measure the power for these two resistances. So let's click this square in order to use the space. Let me copy this display with this line, with this power measurement device. So I want to copy it here, and then I will paste it somewhere. So this will be the power of the first resistance. I will keep it here, and then I will paste it once again. So this will be the power for the second resistance, Okay, and I will keep it here. So first of all, let me make it instead, rename it. So it will be R1 instead of source 1. And this will be PR1. And this is in watts. And let me rename this one also PR2. And this is PR2. And it's also in watts. Okay. So now I want to take the voltage signal from the voltage, and again I need to take it before the RMS block. So you need to make sure that you have it before the RMS block. I want to take the current, so I need to have the current, and we have only one current in the circuit, so it's the same current for all blocks. For the second resistor, I need to have the voltage for the other resistor, again, before the RMS block. And since the current is the same for this all the circuit, I can have it taken from here because it's the same current in for the whole circuit. So let me click this one in order to see this square in order to see all components. Now I can run the circuit once again, and I see that this resistor consumes 48 watts. This resistor consumes 32 watts, and their sum is 80 watts, exactly as the sum of the power delivered by the source. So let me remove this display because I don't need to show any reactive power in a resistive circuit. So I will run it again. And of course, you know that you can calculate the power in the resistance in different ways. So it can be I squared times R. So I square, it will be 4 square, it will be 16, and 16 times 3, it will be 48. Or you can calculate it as V square divided by R. So if you take 12 square, so it will be 144 divided by 4, it will be again 48. Or it is the product of the voltage and the current in a resistor, the power in a resistor, it will be the product of the voltage and the current of the volt. This is the voltage and this is the current. So 12 times 4, it will be 48. Here we have 8 times 4, it will be 32. Or 4 square, it will be 16 times 2, it will be 32. Or 8 square, it will be 64 divided by 2, it will be again 32. So as you see, we have power balance, and you can double check the power using different values. So what we need to remember in this circuit, whenever you build AC circuit, make sure that you are using RMS blocks before showing the value of the variable, either current or voltage. When you are using power measurement device, make sure that you have the appropriate frequency and you select here only one, so we don't need to show the DC component and other harmonics. And you need to make sure that you connect the voltage and the current before the RMS block. So you need to have the instant time domain value of the voltage and the current. So this is why it is continuous power measurement device. So this is the AC circuit, how to build a resistive, simple resistive AC circuit, and how to measure the currents and the voltages and the powers in this circuit. And before ending this circuit, let's show the scope. So we can show the scope. So I'm typing here scope, and here is the scope. So the scope can show the value or the variable. So here, for example, the current. So let me connect it to the current. So now, sorry. So let me connect the scope to the current. So the scope now is connected to the current. I will run the circuit. And if you double click on the scope, you will see the current. So this is the current, as you see, and it has a value, its RMS value is 4. So the peak value will be 4 times the square root of 2, which is something around 5.8, 5.85, something like this. So this is the peak value. So this is the current. So if I want to show the voltage as well, so I can add one channel. So how to add another channel to this scope? You can do right click, go to signals and ports, number of ports, and you can select now 2. And as you see, I have another channel. So let me show on the other channel, let me show the voltage of the source. The voltage of the source, again, I need to take it before the RMS value. And now I will run the circuit once again, double click on the voltage source, and now I see that the voltage is the blue one and the current is the yellow one, and I see that they are in phase because this is a resistive circuit. In this scope, you can do also, you can show the labels of the axis. So you go to a view and then you go to legend to show the legend. So now the legend here says this is the yellow one is the current and the blue one is the voltage. We can go to view configuration properties, and then you go to time, show time axis label. You check this box, apply, and now we see that we have time here. If you want to show the label here for the y-axis, you go to display, and here you have y label. Then you type here, I will type V source in volts and I in the circuit in amperes. So I will type this, apply, okay, and you see that we have the label here. So you can also click on the legend, so you can switch off one of the signals, you can switch it back, can switch the other one, I can switch it back, and so on. So you can show the legend, you can show the labels, you can change the values. As you see, we are showing only one period, and this is why I selected the stop time to be 0.02. So this is the scope. These are the signals that we have. Of course, you can show more variables like other voltages. So, and you can also add more channels using this menu, going to, let's say, let me see. So here in file, you can go to number of inputs and you can click more inputs if you wish. So if I click 3, for example, as you see, I have one more input here. So I go back to file, number of ports or inputs, and I will keep it only 2 for this example, So this is how to build your simple resistive AC circuit.